Greeting to everyone. We are still continuing with the series of trigonometry, but in this case now, we are now looking at the application of trigonometry. So in application of trigonometry, that's when we look at 3-dimension, we work with the trigonometry of 3Ds. So here in a question taken from DBE November 2015, grade 12, we are given here a corner of a rectangular block of wood is cut off and shown in the diagram below. The inclined plane, that is a triangle ACD, is an isosceles triangle having these two angles that are equal. They are all equal to theta, and also ACB is equivalent to half theta, and we know AC is given to be x plus 3 and CD is given to be 2x. Before we even go through questions that are given to us, by judging from the statement, by being told that these two angles are equal, or this triangle is an isosceles triangle, we know that angles opposite equal side give us an isosceles triangle. So if you are given equal angles, that means even the sides are equal. So here AC is equal to AD. This is the information that is given to us. So we know that AC is x plus 3, meaning AD is also x plus 3. Before you even go through questions, this is something that I've just discovered, okay? What else that can we deduce from just the information given to us? Okay, this is the only significant part that we can deduce from this information given to us. So, in this video, we'll cover these three questions to determine an expression for CAD in terms of theta, to prove that cos theta is equal to x over x plus 3, and to prove that if given, or to determine the value of AB given that x is equal to 2. Here is the solution. Okay? From first problem to determine an expression for CAD in terms of theta. Where is CAD? It is CAD in terms of what? In terms of theta. I know that this angle is theta, this angle is theta, and I know that some angles of a triangle is equal to 180 degrees. So this is what I'm going to do. I'll say CAD is equal to, here it will be 180, because it will be a difference of this angle minus theta, which makes it be 180 degrees minus 2 theta. So this is 1.1. Okay, so now I'm going to 1.2. I'm required to prove that cos theta is equal to x over x plus 3. How am I going to prove that? To prove that, I will use the formula that will be provided to you that include cos. Here I have a triangle, but this triangle is not what? Is not a right angle triangle. So when we work with those triangles, of which is an acute and obtuse angle, we have this formula that says that a squared is equal to b squared plus c squared minus 2bc cos of a. So in this case, look here, this is the side that is opposite to an angle that we'll be working with. So in this scenario of this triangle, if I decide to pick this angle, so a side that is opposite to this angle is AC. So it means AC squared is equal to and sides that include this angle, of which is CD and AD. So it should be CD squared plus AD squared minus 2CD AD cos. So in this scenario, it's theta or it's D. All right. So if you can look carefully now, my AC, this is AC, of which is x plus 3. X plus 3 squared is equal to CT. CT is 2x. 2x squared plus AD is x plus 3. X plus 3 squared minus 2 into CT is 2x. AD is x plus 3 cos theta. Okay, so if you can look carefully, if I decide to take this one to the other side, it becomes, from being positive, becomes negative. So the 2 cancels. So meaning I'm now left with what? If I take this to this side, it becomes 2 into 2x, x plus 3 cos of theta is equal to, this is the only thing that is remaining on my right hand side, of which is 4x squared. So if I distribute this one throughout, it should be 4x. Let me just keep it like this. X plus 3 cos of theta is equal to 4x squared. So if I decide to divide both sides by 4x, I'm now left with x plus 3 cos of theta. Here, this one will just kill 1. I'm left with only 1x, which makes cos of theta to be equal to x over x plus 3. Meaning we managed to prove that cos theta can be written as x over x plus 3. 1.3. Okay, so in 1.3, I'm told that if it is given that x is equal to 2, calculate AB, the height of the piece of wood. All right, let me go for AB. Here's AB. All right. So now I'm told that x is equal to what? Is equal to 2. Meaning here, since I have x plus 3, if I replace x by 2, that means this side will be 5. Okay, here I have an angle half theta. Alright, so what can I do here to find AB? If I have an angle and I have an hypotenuse side, I can use sine of theta to find opposite over hypotenuse. But an issue is that I don't know theta. So first thing first, let me find theta. How do I find theta? From 1.2, I know that cos of theta is equal to x over x plus 3. So this means that cos of theta, being told that x is now equal to 2, is equivalent to 2 over 2 plus 3, which is 2 over 5. So I can get theta by saying cos inverse of 2 over 5. So which is equal to, okay, you will then punch your calculator, you will get the answer. Alright, so from here, this is my theta. Okay, from my theta, now I have theta. You see, now I have theta. So if I want to find AB, now I can say sine into theta, of which is cos 2 over 5. Look carefully, it's sine. Okay, here it's half. I hope you still follow. Because here my theta is cos, second function, it's a second function cos 2 over 5. So you will get your answer. Okay, here, remember that an angle here is half theta. So sine half into this, of which is theta, is equal to opposite over hypotenuse. So my opposite here is AB over my hypotenuse here is 5, meaning my AB is 5 sine into half cos, second function, 2 over 5. So if you punch your calculator, you will get a specific value of A over B. I hope this video was very fruitful. Looking forward to meet you in my in oncoming videos on this series. Thank you. Don't forget to subscribe, please, 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 please.